right, so today we're going to talk about something called inscribed angles. And I introduced you to this term the very first day we talked about circles, and I said we'll talk about it later. Well, it's later. Okay, so we're going to look at inscribed angles today. And as a reminder, inscribed angles are angles whose vertex are on the circle. So their vertex is on the circle. We've already talked about central angles, and this angle O here is an example of central angle. The central angle, the vertex is on the center. Sorry, it is on the center. My sleeve keeps hitting the board. The vertex is on the center of the circle. Okay, so inscribed angle, the vertex is on the circle itself. Central angle, the vertex is on the center of the circle. As far as the legs of the angles, okay, for my inscribed angle, the legs are made of chords. So the legs are chords for your inscribed angle. For your central angle, the legs are radii. Now we learned with central angles, we learned this back in chapter 1, that if we know the measure of the central angle, we know the measure of the intersected arc. Right? So if my central angle is 50 degrees, that means my arc must also be 50 degrees. There's the changing color, I don't know. Just go with it. So if the measure of the angle, central angle is 50 degrees, the measure of the arc is 50 degrees. Right? We learned that back in chapter 1. We've talked about that already with chapter 6 here. So today we're going to focus on the measure of inscribed angles. So the measure of an inscribed angle is always equal to half of the intersected arc. So if my inscribed angle measures 50 degrees, that means that the intersected arc, the arc it opens up to, is twice that, or 100 degrees. I'm sorry, I don't know why I tried blue, red, blue, back.
What happens if you just draw like a straight line? Like
It's usually, it doesn't change like in the middle of writing. I don't know.
Yeah, that is.
I don't know. I don't know. I don't get it. Whatever. All right. So anyway, the measure of the angle is half of the intersected arc. Okay. So what if my arc is 120 degrees? Now it's going to be, if it's 120, then it's going to be 60. All right, so everything we're going to talk about today is based on the fact that the angle is half of the measure of the arc. Now, we are going to prove why this is, and I'll explain to you why this is, but it literally takes about 30 minutes to go through this proof. Okay, so we're going to save that for Thursday. Yeah, spoiler alert, that's what's happening on Thursday. So I'm going to ask you to trust me for right now why this is. We're going to go through it all on Thursday, because it is pretty involved. All right, so we are going to look at several conjectures. We're going to look at four more conjectures, and then we're just going to practice them. All right, so let's start with this one here. This says inscribed angles that open to the same arc are congruent. Okay, so notice that the blue angle and the red angle both open up to this 80-degree arc. Right? If two angles open to the same arc, then the angles have to be congruent. So if I just look at the blue angle, if the arc is 80, I know the angle has to be 40. Well, this is just another inscribed angle here, my red angle. It has to be half of 80 or 40 as well. So typically what happens is they wouldn't list one of these out. Like they would not list this. They would not list this and they'd call it X. Oh, they would call it X. And they'd say, what's the value of X? And so that you'd have to notice, okay, both of these angles open up to this arc, so therefore the two angles have to be congruent. That's typically the way it would look. Okay. All right, next one. Next one says angles inscribed in a semicircle are right angles. Angles inscribed in a semicircle are right angles. So if I have a diameter drawn in, which I do, I know then that I have a semicircle, right? What is the value of the arc of a semicircle? 180 degrees. So think about this. If I know that's 180 degrees, I know this is 180 degrees. This is an inscribed angle that's opening up to 180 degrees. So what's half of 180? 90. So that's why it's a right angle. So any inscribed angle that you have that opens up to a diameter or to a semicircle is going to be a right angle. Is that okay? Okay, the next one. The next one is called a cyclic quadrilateral. Okay, a cyclic quadrilateral. It just really means you have a quadrilateral inside a circle. Okay, its vertices are on the circle, called a cyclic quadrilateral. The opposite angles in a cyclic quadrilateral are supplementary. Okay, so the opposite angles in a cyclic quadrilateral are supplementary. So let's figure out why that is. Let's just focus on angles 1 and 3. Okay, let's just focus on 1 and 3. So let's look at angle 1. If I follow the legs of angle 1, notice that it opens up to that arc, right? Now if I follow the legs of angle 3, so follow the legs of angle 3, it opens up to this arc. So how much of the circle have I highlighted? The whole thing, right? The whole thing, which is how many degrees? 360. Well, notice angles 1 and 3 are both inscribed. Right? So half of 360 is 180. So that's why it works. Again, trusting me that I know what I'm talking about with the inscribed angles. I haven't proven that part to you yet. But that's why the opposite angles here are supplementary. Is that okay? All right, last one. Last one says if you have parallel lines that intersect a circle, then the arcs between the parallel lines are congruent. So these two parallel lines cut congruent arcs. So the arcs between the parallel lines are what are congruent. Not above, not below, just the ones in between. So let's talk again about why that might be. So if we have parallel lines, and I draw in a transversal, don't forget we have congruent angles, right? We have congruent angles. What kind of angles are those? Alternate interior angles. So alternate interior angles are congruent. Well, if these two angles are congruent and they're both inscribed, that means that the arcs are going to have to be congruent. Right? So think about, if you want an example, if this is 40, then that means this angle has to be 40, which then would make my arc what? 80 and 80. It gets worse as the day goes on. There we go. 80 and 80. All right, so that's all of the new conjectures for circles that we're going to learn today. Now we're just going to use them. Okay, we're just going to practice. So we're going to start off by doing some together, and then I'm going to let you try some, and then we'll go back and forth. So here's our first problem. For a lot of these problems, I like to just find measurements first, and then go back and answer the questions later, because the order that is listed on the left isn't always the best order to attack them in. All right, so we have that, we have an arc here that's 80 degrees. I know we have an inscribed angle at N opening up to 80 degrees, so that angle has to be 40. Has to be half of it. Okay, so now I also see I have a diameter. Xn is the diameter, which means I have a semicircle on both sides. So if xm is 80, that means nm has to be 100. Oh, 100. There we go. Is that okay? So let's see if we can answer some questions. So xnm, the angle is 40 degrees. Arc xn, that's a semicircle, so that's 180 degrees. And then arc nn is 100 degrees. Questions on that? All right, next one. All right, so in this one, we see that AB is a tangent. I also see we have a central angle in this one, right? We have an angle there that's on the center of the circle. So if this arc is 120, that means that angle must also be 120. Okay. All right, hold on. Now I'm starting to get mad. All right, so this would have to be 120. Okay, I also have an inscribed angle that's opening up to that arc. So what does that make that inscribed angle? 60, because it's half of that intercepted arc, right? Okay, now we also have a special situation going on here. So AB is a tangent, but it's like this 60-degree angle here, its vertex is on the circle. It's in terms of measurement, it acts just like an inscribed angle. Okay, so when you have a tangent and a chord that make an angle, okay, this angle acts like an inscribed angle. Okay, so it acts just like an inscribed angle, meaning the angle is going to be half of the intercepted arc. Okay, so it acts just like an inscribed angle. So this angle is 60 degrees right here. The arc that it intersects is Z. That means Z has to be 120 degrees. All right, now we can find Y, because we know those three angles together make a line. Right, so 60 and 60 gives me 120, so Y then has to be 60 degrees as well. We could have also looked at my arcs all the way around. I have 120 and 120, so all I have left is 120. I can work backwards to get this arc. I know they didn't ask you for that, but that's 120. Then divide by 2 to get my angle, which would give me 60. All right, so X is 120, Y is 60, and Z, I lost it. I can't find it. Z is 120. Is that all right? All right, number 3. Number 3, we have a triangle inscribed in a circle. Okay, you can see a triangle inscribed in a circle, but I also see then inscribed angles. Okay, so my vertex here for angle C is on the circle, so it's an inscribed angle that opens up to 70 degrees. So what does that make C? 35 degrees. I can see that A opens up to a diameter. If angle A opens up to a diameter, I see that that then is a semicircle, which I know is 180, so half of 180 is 90. Good. So now I can either use my triangle to find B. Or, again, I have a semicircle, so if I take 180 minus 70, I get 110. Right? Divide that by 2, you get 55. So let's see, A is 90, B is 55, and C is 35. Is that okay? All right, next one. I want you to do the next two. Do the next two. I'll give you a couple minutes. I want you to do the next two. So this is an inscribed angle. That opens up to 120 degrees. So it has to be half. Then when you have another, it acts like an inscribed angle because it's rotating on the surface. So the arc is double the angle. That's 60 that has to be. Is that okay? Okay.
No, I'm fine.
Anyone need more time? All right, so let's look at number 4 here. So very similar to the last one, right? I have angle C opens up to this 140-degree arc. That makes angle C 70 degrees. A opens up to this 100-degree arc, so half of that would be 50. Then I can use just my overall triangle to get 60. We could have also solved for the missing arc, right? Take 360 minus 100 minus 40, and get 120. Then I can work backwards to get that angle. Is that okay? All right, then the next one is a throwback to last week. Well, the last week we were here, I should say. So what happens when you have a radius and a tangent that intersect? You have 90-degree angles. So we have a right angle here and here. So you can use the fact that there's 360 degrees in this quadrilateral to find x. Or remember, this is also a kite. Right? This is also a kite. And we talked about there's 360 degrees. That always has to be 90, and that always has to be 90. So these two angles have to be supplementary. That kind of ringing a bell? It's been a long time. That makes x 140 degrees. Is that okay? All right, next one. Next one here. Okay, again, so we have AD is a tangent and AC is a diameter. So we just talked about a radius and a tangent. When they intersect, they form a right angle. So now I can use that to solve for C. Right, I have 90, I have 54, so that makes this angle 36. If I look at my triangle. Okay, so now if angle C is 36, I can find its intercepted arc. Here, AB has to be twice that, or 72. I also see, since AC is a diameter, I have a semicircle. Right? If AB is 72, that makes CB 108. So let's see if we've answered all the questions. Angle A is 90. And let's see, AB, arc AB we said is 72. Angle C is 36. And CB is 108. Any questions on that? All right. This one is just like the ones we were doing before. Do you want to go through this one? I don't know why I put 3 of those on there. I just got really excited about those apparently. All right. Let's do this one then. All right, so this one, I see I have 29 degrees. It's an inscribed angle. If I follow that out, it intersects arc R here. So what does R have to be? Has to be 58, right? Because this is an inscribed angle of 29. Double it, I'll get 58. Right, if I follow the legs of this angle right here. There's its intersected arc. But I also have another angle that opens up to that arc. Right? This angle down here also opens up to the 58-degree arc, which makes this angle down here 29 degrees as well. Okay, now I have vertical angles here in the middle, 87 and 87. So now I can use either triangle and find the missing angle of my triangle, right? Okay, so that's going to be, I believe it's 64 and 64. So 180 minus 29 minus 87 gives me 64. Okay, so now these are both inscribed angles. If I follow it out, this big arc P here is going to be twice that, or 128. Okay, now another throwback to when we started circles. Notice we have 2 congruent chords. If we have congruent chords, remember that means we have congruent arcs. Okay, so if I take 360, we'll subtract what I know. I have 58 and 128. So that gives me 174. Divide that by 2. So that's split it evenly. I get 87 and 87. Questions on that one? All right, now I'd like to give you a couple minutes to work on this one. Okay, so just as a reminder, don't forget when we have radii and we have a chord here that joins them, what kind of triangle does this make? Isosceles. So don't forget, because my radii are congruent, it actually ends up making isosceles triangles. That helps me because then I have base angles and a vertex angle, right? So work on that for a couple of minutes and then we'll go over that one.
Is Kay asking for the angle?
Yes,
right there?
K is an angle.
We should get a lot of repeat numbers, right?
Yes.
Wait, don't tell me what you think it is. What would you describe? It's very large. Yeah, was it like any now? Yeah, like
With an angle. Asking for the
Yeah, but that's it.
First of all, oh, I could have just. It looks like you're saying that I could write that.
Oh, wait. Yeah, but it also
And tomorrow.
but not the people say art. Oh, but yes, it's that's why I'm like, what do we do that anyway? You don't play this thing, why that happen?
All right, so let's go ahead and start. Let's take a look at what we can do here. I'm going to try and, if I see different ways you could have found that angle, I'll try to point those out as well. Because most of these, there's more than one way to find that angle. Okay, so first of all, if I start with this triangle here, I know it's isosceles, so my two base angles have to be 50 and 50. Okay, which means then, that's a total of 100, which means my vertex angle then has to be 80. I have another isosceles triangle up here. So again, my base angles have to be congruent. So there's 25 and 25, the total of 50. So that means this angle has to be 130. Okay, so now I have a linear pair here. So if E is 130, A has to be 50. I have vertical angles with A and D. I could have also done a linear pair there if I wanted to. I can now solve for B. I can do like 3 angles to make a line, however you'd like to do that. So that would also be 50. So now let's look at the arcs associated with all those central angles. So if A is 50, I know G has to be 50. If B is 50, H has to be 50. C is 80, M has to be 80. If D is 50, N has to be 50. E is 130, P has to be 130. Okay, so there's all of those. Now J and F, those are both radii and tangents intersecting. Those both have to be 90. Where are we? K here, a couple ways to get K. So these three angles together would form a line. So 90, 50, this would have to be 40. Or I could have looked at its intersecting arc here was 80. So half of that would be my inscribed angle of 40. Okay, notice we have parallel lines here. I didn't have to use them, but it does cut congruent arcs. So that's why this is 50 and that's 50 as well. Okay. I think I got them all right. All right. Okay, so I know that was a lot, and I did a lot of practice because it just makes things way easier. But your homework tonight is out of your book. Okay, and I know it looks like a lot. They go a lot faster than what we think. Do your best to work on them. If you get them done, great. If you don't, okay, there'll be a little bit of time where you can work on that tomorrow. Okay? So don't forget, our book is online, so you can pull up the online book and work on it. Now, I don't think I put this on your notes, so I would make sure you write this down.